So today we're going to go to the next level. We started with 1 point, and then we added a point to make a line. And now we're going to work with planes. And again, this information comes from Chapter 10 of the ebook, which again comes from that disc that comes with your book. And got a few principal rules that we're going to be following today. So first of all, what is a plane? It's a flat area. Technically in mathematics it goes on forever in every direction, but any 2 points could be connected by a straight line lying on this surface. Some of the different ways that we can define a plane: any 3 points not in a straight line will give me a plane. One other thing to notice too, lines project, or points project, just like they did when we were talking about points and lines. So A and B and C are all projected from one view into another. Another way you can define, which is pretty much the same definition but a different way of wording it, a straight line and a point not on that line. Similar idea. 2 intersecting lines. And one thing that's really important about this is they are intersecting lines. They don't just appear to intersect, they literally touch each other. Because as we know that it's possible if I just have one view from one of these lines to be in space in front of the other. But if they truly intersect, then we can create a plane out of those 2 intersecting lines. And there you see them with the endpoints connected. 2 parallel lines, and again, really parallel lines. They don't just appear parallel in one view, they are truly parallel lines. Those 2 parallel lines will create a plane as well. And then if we have 2 lines that intersect, forming a plane, that intersection will project as well. And that's pretty true for a lot of what we're going to do. Intersections project into other views. So as you can see, in addition to A, B, C, and D projecting from one view into another, so does the intersection. And that's, again, huge for what we're going to do today, a lot of intersection stuff. If 2 lines are parallel, if they're truly parallel, no matter which view you view them in, they will appear parallel in that view as well. So if these are my horizontal and my front views and I project to create my profile view, they will appear parallel there as well. So we're going to have to classify some planes, and it's very similar to what we did with lines. So remember, we classified lines by where we saw their true length. So if we saw their true length in the horizontal plane, it was a horizontal line. So now we're going to talk about true shape and size. The textbook actually calls it true shape and size. Some of my handouts call them true size. I usually call them true shape, but they all mean the same thing, and we'll label them as TS. So a true shape is where we can actually see the full shape of the plane, which means all edges are true length, and then the shape itself is true shape. We'll talk more about that in just a second. But here I've got the true shape in the front view, so it's a frontal plane. Here I've got true shape in the horizontal plane, so it's a horizontal plane. And again, pretty obvious when you look at the front view, it's just an edge. And then here we have a true shape in the profile plane, so it's a profile plane. And then when we talked about lines, I kind of did a process of elimination. So it is the true length in the front, the profile, the horizontal, and then when we talked about lines, we said, does it show up as a point in the horizontal plane? If it showed up as a point in the horizontal plane, then it was a vertical line. So very similarly, when we have a plane, if the plane shows up as an edge in the horizontal plane, then it's a vertical plane. Now, technically, this would be a vertical plane as well, right? It shows up as an edge in the horizontal plane, so this is vertical. But because it's parallel to the frontal plane and the true shape is in the frontal plane, that takes precedence. So this is a frontal plane. The other one shows up as an edge view, and this one too as well for that matter. It's an edge view up here. It is vertical, but it's parallel to the profile plane, so it's classified as a profile plane. But here we have it as an edge view, and it's not parallel to any of the 6 principal planes, therefore it's just simply a vertical plane. And as you could probably guess, if you have a plane that's not parallel, or that is not true shape in any of the 6 principal planes, it's an oblique plane, and of course we're going to have to create some auxiliary views to find its true shape, which we'll talk more about next. Well, actually, we'll talk about intersections first, then we'll talk about that. So if a line lies on a plane and it intersects with any lines on that plane, those intersections will project. So I mentioned that earlier with the two intersecting lines, but also if there's just a plane and a line. So for example, here I have a line in the front view that goes from point AF straight across and hits CB, and it creates a line, or point EF, excuse me. I can now take this point and project it up. And here's the most important thing: pay attention to what line BC, or what line point E is sitting on. It's on line BC. So don't just project up and stop at the first line that you run into. Make sure it's the correct line. So this is BC, so I'm going to project this up to BC. That's now going to be point EH, and I can now construct the view of this line up top, which happens to be the true length line because this line is parallel to the horizontal plane. Therefore, this is a true length line.
So we have to find true length and true shape. We have to label both.
Good question. Really, you're going to be labeling true shape, but you'll need to find the true length for the next step. Good question. So yeah, you'll just have to label the true shape when it's all said and done. But I just want to make sure this makes sense. It's what we've been doing, but it's now on a plane. We're going to construct a line down here in the front view that is parallel to the horizontal plane, and that then allows us to find a true length line up here. And let's talk a little bit why that is. Let's switch to Inventor here. So here I've got a plane that's sitting inside this box, and it's an oblique plane. It's not parallel really to anything. But if I take a look at the, so no matter which view I view it from, here's the front, here's the right side profile. It's foreshortened in each view. If I view it down from the top, again, it's foreshortened in each view. But I've got this line on it, and I want to eventually find the point view of this line. So if I have a true length line and I look at its point view, that means the plane will be an edge view. So the whole reason that we're going to find a true length line is so that we can then find a point view of that line. Once we have the point view of that line, that entire plane will be an edge view. So does that make sense? So if we find the point view of a line on this plane, that also will be the edge view of the plane. Why do we want the edge view of the plane? Because then we want to go perpendicular, or I should say we'll create a hinge parallel to it, but the view will be perpendicular to it, and that will allow us to look straight at the plane. And let's see if it'll let me get it. And then that will be true shape. So our goal is to look our eyes perpendicular to the plane so that we're able to see the true size and shape, or the true shape, if you will. But working backwards, in order to do that, we need to find a true length line, then find its point view, which will also be the edge view of the plane. Then we can find the true shape. So let's review a few more of these. Okay, so honestly, I'm jumping ahead a little bit here because they talk a little bit more about intersections before going on to true shape. But here I've got a point in the plane, and I want to find this point in another view. In order to do that, you're going to make another intersection. So I'm going to use my ray command, and maybe I'll start at A and run through E and see where it hits BC. And then I'll project that down. Or I could start from C, run through E, see where it hits AB, and project that down to AB. Or I have a third option there as well. All of them will come up with the same answer. But let's say I started a ray from A and I run through E, and I'm using the ray because if you just use the line command, you're going to click here and it's going to stop here, and that doesn't really give you your intersection. So a ray from A to E runs through BC here. Like I said, don't just project and stop at the first line you run into. This line is AC, but this intersection lies on BC. So I'm going to project this down to BC. I can now draw a ray or a line from A to this intersection. And I can now take point E and project it straight down to find where E is on this plane. Now, why in the heck are we doing this? Because eventually we're going to talk about the relationship between a line and a plane and another plane, and find their intersections, and this will help us find those things. So here's where I was getting to when I switched over to Inventor. Again, the edge view of a plane is seen in any orthographic view showing the end view of some line. So if I create a little strike line here, a horizontal line, then I'll get my true length up here. Now, one thing I do want to point out to you, I have really an infinite number of horizontal lines I could have created in this front view. No matter what line I create here, in this view, it's going to be parallel to this one. So it goes back to the idea of parallel lines are parallel in every view. So if I drew a line down here, when I projected the true length, it would be in here somewhere, but it'd be parallel to this one. So therefore, my hinge doesn't change. It's still going to be perpendicular to this line. I like to start at a corner point because it's one less point to project. If I drew a line down here, I'd have to project a line up to AB, and I'd have to project another line up to BC to get those. So I'm always looking for a shortcut. That's why it starts on the corner here. I've only got one line to project. So if this is true length, I'm going to construct a hinge perpendicular to it, and it really doesn't matter, which way you go. If I go off the top, or excuse me, to the left or to the right. Then I can bring across A, B, and C with some rays. Now A and E should line up. You don't necessarily have to bring point E across. Then I'm going to go back 2 views, 1, 2. Here's my C offset, my A offset, and my B offset. And if it all works out, they should line up in one straight line. If they don't, then we've got something wrong. A bad hinge, a bad true length line, a bad projection, something's off. If you get to this view and they don't line up in one straight line, we need to go back and look at some things. So as you can see here, the E1, A1, since E is the closest for that true length. That's the point view of this line, which gives us an edge view. You do not have to label point view or edge view on these planes. True shape TS is really all I'm going to have you label. This true length line, Blaine asked earlier, do we need to label this? You're probably going to erase it when it's all said and done. You don't really need to keep it. Once you've created this hinge and projected, you don't really need it. So now that I've got the edge view, if I create a hinge parallel to that edge view, then the resulting view will be a true shape. So I'll create a hinge parallel to the edge view, project all points across, go back 2 views for my offsets until I have the true shape. And you don't have to label the edges true length. That's, as far as I'm concerned, that's all the same. If it's true shape, those edges have to be true length. So I'm looking for TS is what I'm looking for. You don't have to put the TL labels on. And as always, correct labeling of all your points, of course. So eventually, next time, we're going to start talking about bearing and slope, but we're not going to worry about that today. We're just going to talk about projecting planes. So in AutoCAD, I've got another sample file that we can work through together. So if you go to New, and then our Templates folder, and then Additional Files, then you should see one in here called Plane Practice. So you can save this to your class folder, of course. And just call it Plane Practice. Again, you can refer back to these later on exams, that sort of thing. I need to change my crosshair colors. I got dark blue and black. There's no way you can see that. That's better. Okay, so the first thing I want to say about this one is if I get away from you on doing this, the solutions are actually already in this drawing. If you go up to the layer list and click the drop down and find the solution layer, that layer has been frozen. That's why there's this little snowflake. If I click on that to thaw the layer out, then you can see that I've basically put the solutions up above these. So you can go and refer to that if you get lost or just want to go back in and see it. So first of all, let's classify these. I don't see any edge views, so I don't see any true shapes. There shouldn't be any profile views because I'd have an edge view in the front, and I don't see them showing up as a vertical edge on top. Remember what this is. This is actually, if it helps, you can connect these and see it as a plane. So those aren't edges. That's just two intersecting lines creating a plane is what we're dealing with here. So what kind of planes would all of these be? Oblique. Same thing with these over here as well. Okay, so as I take a look at the first one, here the goal, and this is kind of similar to the first drawing that you guys are going to do today, you've got to lay out line BZ in the horizontal plane. So it's just as simple as creating our projected lines and labeling the points. So BF is going straight up into the horizontal plane. And again, don't just stop at the first line, make sure it makes sense. Point B is sitting on line MO. So where this intersects MO, I'll go ahead and draw a point. And then I'll erase this ray. And then same thing for point Z. Take this straight up. Again, don't just stop on the first line you hit. Z is on line NO, so I'll make sure that's projected up here to NO and place a point. It looks like I'm getting a midpoint. It might be at the midpoint, or it might. It looks like it's right on the midpoint. So I think that's okay. Go ahead and erase that. Draw in my line, and then label the points appropriately. So that one's going to be BH, of course, and then ZH. Make sense so far? You'll be doing a lot of that, projecting intersections. So now let me make it a little more difficult. As we look at the second example here, Y is pretty easy to find. Y intersects PQ, so I'm going to take a ray and project that down to the front view. This is line PQ, so that means the point is right there. So again, you can label that appropriately. Now, point X isn't quite as easy because I take X straight down and it's just going to tell me that it lies on that vertical line somewhere. What a lot of people have a tendency to want to do is to maybe take this offset value. And you can't do that unless we know for sure it's a 45-degree angled slope plane, which we don't. This distance is not going to be the same as it is down here. We've got to go 2 views in order to measure distances. So what you might end up having to do sometimes is create your own intersections. So for example, let's find where these 2 lines would intersect each other. If XY continued out and QR continued out, where do they hit? So I'm just going to draw a couple of rays to help me do that. So I'll go from Q through R, and then another one from Y through X. Now where they meet, I can project this intersection down. And then this point that I just created, if I look at the relationship between it and RQ, they all lie on the same line, right? This new point, R and Q are in the same line. So that means in this view, that will hold true. If I draw a ray from Q through R, where it hits this line is going to be my point. Here through R, that's going to be my point. And then if we look up here at the relationship of this point, point X, and point Y, they're all in a straight line. So if I draw a line from this point to Y, where it crosses RP is where X is. It's the same thing down here. If I draw a line or a ray from this intersection I created out in space to Y, where that crosses over PR is going to be my point. And then I have a lot of construction lines to delete. So that'll be my point XF. And then most importantly, draw that line in. So you'll run into a couple of those on today's assignments where you've got to create your own intersection. Speaking of creating your own intersection, on the next one, we've got a point Y sitting in this plane. And like I said earlier, I really have three choices. I could start a ray from P running through Y and where it hits QR. I'll give you that visually here. So maybe from P through Y where it hits RQ. Or instead, I could take R through Y and wherever it hits PQ, I can project that. Or I can take Q through here and wherever it hits here, project that up. Or really, for that matter, I could create any intersection. I mean, it could be something like this. Like through there, and then let me just extend this real quick. But the reason why I don't like this is I've got to intersect two lines, or I've got to project two lines. I just want to do one. Yes, Blaine?
I don't have that picture on here.
That's weird. Why would you not have that? Oh, okay, that's why I must have an older version that's a drawing file, not a template file. So change this to templates, and then I must have had an old one that's still a drawing file in there. I didn't realize that. Sorry about that. Okay, so again, what I was just saying is I don't want to do something like this because then I have two intersections to project. The answer will still be the same. It's just more work. So I'm going to start a ray from one of those points. I'll do P through Y. Where it hits RQ, I'm going to take this intersection up. And then I can now create another line or ray from P running through that intersection. And I know that Y lies on this line where? Well, now I can take Y and project it straight up. And then I can place a point there. And then delete some construction lines. So again, it's all about just making an intersection that you can then project. So if we take a look at the next one, there's lots of different ways you can do this one. If you look up here at my sample ones, I did a couple of them that were a little more involved because here's point W floating out in space. And I created a line that ran from V through W and found out where it intersected ST. So I end up with this intersection way out in space. And then project that down and work back from there. You can actually make it a little bit easier just by making some sort of intersection from W to T, for example. Now I did draw on the outside. You don't necessarily have to do that. But if I were to draw a line from this W to this T, I could just take this intersection down where it intersects UV. So let me actually change my layer this time. So where it intersects UV, I'll take that down. Here's UV right here. So T goes through that intersection. So So I'll start at T through this intersection that I just created, and then W can come straight down from there. And then where they meet right here would be my point W. There it is. So again, various different ways to find that one, but they should all end up with the same answer. And then again, I'll label that WF.
So we don't have to put the boxes or websites?
You don't have to, no. You can if you want. Sometimes it's more helpful to see it as a plane, not just two lines. But I don't care either way. So now let's talk about finding the true shape or true size, either way. So as I look at these two planes, it is an oblique plane because I don't have any edge views or true shapes in any of my principal planes. Do I have any true length lines? Yeah? So JK here is parallel to the frontal plane, so that means JK down here is true length. JL is parallel to the horizontal plane, so that means JL up here is true length. So I don't have to construct a true length line. So I've got true lengths. You don't have to label them, but just for our discussion purposes, I'm going to go ahead and label mine as we talk about this. So those are true length lines. And again, our goal is to find a true length line so that we can create a hinge perpendicular to that line, which will result in a point view of that line, but also an edge view of the entire plane. So in this particular case, I don't really tell you which one to come off of. If I come off down here, I have an auxiliary incline view, right? And if I come off of the horizontal, I get an auxiliary elevation. So you can really come off of either one, but I will tell you that what we're going to talk about next time is the slope of a plane, and just like a slope of a line, it's got to be in an elevation view. So just knowing that I'm usually going to be projecting off of the horizontal, that's what I'm going to do right now. So similar to what we did when we just had the line, I'm going to create a hinge perpendicular to that true length line, and then I'll move it down so I can make sure I can project across all those points. Now you don't have to do all the labeling right now as we're doing this together, but I'm going to do that while some of you are catching up to me. So I'm going for H to 1. Then I'm going to start projecting. And again, if I leave you behind at all, the solutions are up above, so you can take a look at them. So if I get away from you, rather than try to get caught up, just kind of sit back and absorb it as I go. So I'm going to create a ray from J perpendicular to the hinge that should run through L, because it's going to be a point view there. And then another ray from K perpendicular to the hinge that I created. Then I'm going to offset. I'm going to set it to offset into the current layer. And we're going back two views, so 1 and 2. J and L have the same offset value. That's what's going to give me a point view. So there is my first value. And I'll go ahead and place a point as I go so I don't get lost here. Recommend doing a point at a time because you know, a lot of you saw it when we were doing lines. It's easy to get mixed up and draw them the wrong way. So then I'll go down for my K offset value here and find my next point. So as I mentioned, this is the edge view, this is the point view of that one line. You do not need to label PV or edge view or anything like that. You do need to label the points properly though. So this point would be K1. And then would the second point be L1, J1 or J1, L1? L1 first, because it's the closest. Thank you. All right, so now that we have an edge view, now we can create a hinge parallel to that. And then we'll find our true shape. So once more, I'll draw a line, shift right click parallel, hold my mouse over this line, and then bring it up to where it's parallel. And then once more, I'll do some labeling, going from 1 to 2. And then I'll draw some rays. Go back to my projection lines layer. So I got a ray from L1, J1, and another one from K. Now for my offsets going 2 back, looks like L is the closest one. So there would be my first point. And again, I'd recommend you try to do just one at a time so you don't get them mixed up. And then J is all the way down here, but lies on the same line. Looks like I'm cutting into my sample one up here. So I'll place a point there. And then my K offset would be here. And then, of course, all the proper labeling. So L would be the closest, and J. All right, and then I can connect those dots. And then as I said before, all you've got to do is put in the TS label. You don't have to label each edge true length, because by definition they have to be if that's the true shape. So I'm going to check myself compared to what I did before and use the area command. I just typed in AA to do that. Yes, I got the same answer I did before, so that's good news. 1584.5442. So if you take a look at my solution ones, I did it going up in an elevation, and then I also did it down in an auxiliary incline. And in either case, the area should be exactly the same. It's the same true shape, just like it would be the same true length when we were talking about lines. All right, I'm going to do one more, and how about you guys just kind of sit back and watch me on this one to get a good feel for it, and instead of trying to concentrate on doing the same thing I'm doing. So on this one, it's an oblique plane again. Do I have any true length lines this time? I don't, right? I don't have any sort of parallel relationships. So I've got to create my own. And the easiest way to do that is usually to start at one of the intersections in the front view. Well, first of all, I could do it in the horizontal and come down and find a true length line here. But like I said, we know we're going to be talking about slopes next time, and those need to be built off of the horizontal. So I usually draw my horizontal strike line in the front view. So I'm going to just draw this straight across. It could be a ray, it could just be a line like I just did there. And then that's going to project up to line XY. So I'm not going to stop here. It's got to go to XY. And then back to Z. So that's my true length line. And I'll show you guys one more thing here. I mentioned you could draw really any line here. So let's do that and see what the end result is. There, did I grab the right point? I did. And then this is where it intersects YZ. So that'd be right there. And that intersects XY. That would be right there. And I'm going to use my angular dimension tool real quick, and it should come back in my command line that those two lines are parallel. So that one and that one, lines are parallel. So it really doesn't matter what your horizontal strike line looks like. I like the first one because I only had to project 1 point, right? It's half as much work. So I'm always trying to use an existing point or corner. And then if they're parallel, then obviously the hinge perpendicular to it is going to be the same. So from there, it's really what we just got done doing. Whoops, keep that one, or that one. So I'll show it to you one more time. I'll just work a little faster this time. So I'll create a hinge perpendicular to that strike line. And then like I said, after you've got this, you can leave this line or you can erase it. I really don't care. So you can leave it just in case you missed something and you want to go back and see why you missed it. That might offer a clue if these two things aren't perpendicular to each other. But you don't have to label the TL or anything like that. So I'll bring all these across. The other thing that you don't have to do, contrary to my slides, is you don't have to give this point a name and show it in the next view. So you really don't need that one. So I also said that I usually do one, or that I recommend that you do one at a time. I'm going to do all three and just keep track of which one's closest. So X comes first, then Z, then Y. So X is closest, then Z, then Y. So here's X, and then Z is next, and then Y is next. So those would be my 3 points. And then what I would encourage you to do is, rather than try to connect the dots, draw a line from the first point to the last point. And any in the middle should land on that line. So here to there. Whew. So far so good. And then of course I can go ahead and draw my hinge parallel to that. So you guys know how I'm cheating and getting that to work real fast. I do a lot of shortcuts. So when I'm drawing, when you shift right click to get these options, sometimes AutoCAD will show you some underlined letters, and I haven't figured out why it will sometimes and other times it won't. But just from my experience, if I type E, it'll give me endpoint, M will give me midpoint. If I type P, it will give me perpendicular. If I type L, it will give me parallel. So when you see me do this real quick, I'm going line, shift right click L on my keyboard, and I never have to actually touch it in the sub menu, in case you're wondering how I'm doing that so fast. I hate looking at menus because I end up looking past the one I'm looking for like 5 times before I finally slow down and find it. So I like using shortcuts. There I just did the shift right click perpendicular. I'll show you that again. Shift right click P. I did a line instead of a ray. Ray, a lot of times I feel like I can type it with my left hand faster than I can go up and hit the button. Shift right click P. Shift right click P. Again, going back for my offsets now. O for offset. Again, trying to keep in mind which one's which. X is the closest, then Y, then Z. And of course it helps if I would have labeled the view in between there. But Z is the furthest, which is going to be that one. X is the closest, which is that one. And then that leaves Y right there. Connect those guys, and then label all the points and hinges and TS for true shape. And hopefully it looks a lot like this one. Whew. So again, the strike line, you can leave it. If it doesn't offend me, you don't have to label it. I'm looking for the TS label and all appropriate point labels on all of your views. So let's take a look at the assignments of the day. We're going to be doing planes 1 and 2 today. So when we go to new and the templates and then planes 1, on the first set of these, you are asked to classify the planes. So there's a line below, just use the text tool to type in. Again, your choices are frontal, profile, horizontal, vertical, and oblique. So wherever you see the true shape. And then you're also told to mark TS, true shape, on views showing the true shape or true size. If there is one. If there's not one, you don't have to construct it. So where would the true shape of this plane be? Profile? So what kind of plane is it? Profile. So wherever you see the true shape, that's what kind it is. So you'll classify that one as profile, but there's nothing to label as true shape. I'm not asking you to construct it. I'm just saying if it's there, label it. Make sense? For the second set of these, you're going to use the idea of intersections and parallel lines to finish these views. So for example, if I want to find point D, I know it's going to be straight down from here. I'm going to use this intersection with AB to figure out where it hits AB, then I can connect the lines. With EF and GH, you're going to use the fact that I'm telling you that they're parallel, which means they're parallel in every view, to construct where point H is. On the next one, it's a two-part problem. Find point N in the front view, find point P in the horizontal view. Again, just by creating intersecting lines and projecting. And then this is another two-point problem. You are to find point R in the front view and point U in the horizontal view. So any questions about what you're being asked for on planes 1? Planes 2, you're going to be finding edge views and true shapes. So you're also going to classify them. As you can see, 4 of the 5 already have edge views, so you'll just need to construct the true shape view off of those. This one down here, you'll need to construct a true length line, or maybe there's 1 or 2 already there, hint, hint. And then you can construct your edge view and then your true shape. And that's it for today. We're just going to do those 2.